Okay, let's go ahead and start our last section for the week. Woohoo! 7.4. It's kind of a long section, but there's a lot of graphs on it, so it's 6 pages long, but it's not going to take as long because of the graphs. So this is we learned how to find the x and y intercepts in 7.2. On this section, we're going to start putting the parabolas on the graph, and we're going to learn about things called shifts, like what makes a parabola shift up, what makes a parabola shift right, what makes a parabola shift left or shift down. So we're going to learn about the basic form of a parabola, and then we're going to learn about shifting it according to the equation. So anything that has the highest power, x squared, will graph as a parabola that looks like these. And by the way, these all have arrows here. Just the computer cuts them off for some reason. You know, they're supposed to assume that when they go to the end of the graph, that means they keep on going. But I don't like that assumption, so I put them in. And when you draw them on a test, you do have to put them in as well. So first we're going to talk about what's called the mother function. So let's go up here to the top. So when we have the mother function, it is y equals x squared. It's the basic parabola. So if I asked you to make a t-table, you could do -2, -1, 0, 1, 2. It's usually the basic. When you square -2 times -2, you get 4. When you square 1, -1 times -1 is 1. When you square 0, you get 0. When you square 1, you get 1. When you square 2, you get 4. So that would be the t-table for the parabola. And what it looks like, that means it hasn't been moved left, right, up, or down. That's why it's called the mother function. And generally it has its vertex or a turning point at the origin. And you'll see this one does. So 0, 0 is one of the points. Let's go ahead and put 4s. So we'll go to 2 here. And then we'll go up 4 and down 4. So -2 is 4. I'll go ahead and do it in a different color so that we can see it easier. So -2 graphs with 4. -1 graphs with 1. 0, 0 is what we call the vertex or the turning point of the graph. 1, 1, and 2, 4. So if I asked you to make a t-table and draw a parabola, this is what it would look like. And parabolas are rounded, so make sure you show that it's rounded. That one almost looks square. Sorry about that. It's supposed to be rounded, not square. And it's not pointy. It's not a V, because you'll learn in the next class V's are absolute value graphs, and the parabola is not an absolute value graph. So the reason I want you to learn about this is because I want you to memorize the points. So from the vertex, you go right 1, up 1, right 2, up 4. And then you go left 1, up 1, left 2, up 4. Because that's going to help you graph all of these other ones coming up. So just remember 0, 0, 1, 1, 2, 4. And all you have to do is plug it in. 0 squared is 0, 1 squared is 1, 2 squared is 4. And you don't even have to memorize this side because parabolas are symmetric. So if you can get this side, then you just reflect these points. So if I went right 1, up 1 to get the reflection point, I'm going to go left 1, up 1. If I go right 2, up 4, then I'm going to get the reflection point by going left 2, up 4. And this is part of the big 10-point problem is drawing the parabola. So knowing the mother function, super huge. So this is called the mother function of parabolas. In the next class, you're going to have 10 mother functions to memorize, but you'll have one of them down. You already know how to graph a line from prior classes, y equals mx plus b, so there's 2 down. So that leaves you with just 8 that you'll have to memorize and learn as long as you learn the parabola in this class. So now what we're going to study is what happens to a graph if I add a k to it at the back. Well, if the k is positive, does everybody know greater than 0 just means it's positive? So if the k is positive, what it does is it lifts the graph up. So we call it a shift up k units. So this is the mother function that I just practiced with you to draw. So let's say k is 4. So this says take the mother function and lift it up 4 units. Then if k is negative, so this would really be minus, then k goes down. So if we had negative 4 here, that means take the mother function and shift it down 4. So adding what we call a constant, that means a number, not an x, a number at the end shifts it up. Subtracting a number after the x squared shifts it down. And then the cool thing is, if you memorize the mother function, you already know how to do the points. Over 1, up 1. Over 1, up 1. Oh, if you're going to shift it, then you go, okay, here's my new vertex, over 1, up 1. Over 1, up 1. And then you can do over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. And there's your parabola. You don't even have to make a t-table because we're going to memorize these. 0, 0, 1, 1, 2, 4. And remember, it's not really memorizing. Put 0 in, you get 0. Put 1 in, you get 1. Put 2 in, when you square it, you get 4. So it's not really memorizing, but having those in your head is going to help you draw these. Same thing when you shift it down. So you shift it down 4 units, then you go over 1, up 1. And then you reflect that point. Left 1, up 1. Then you go over 2 from the vertex, up 4. Then you go left 2 from the vertex, up 1, 2, 3, 4. So I can draw any parabola that is in the form of x squared plus a number or x squared minus a number just by finding the new vertex, shifting it up 4, and then going over 1, up 1, left 1, up 1, over 2, up 4, left 2, up 4. I didn't do the 2 and 4 on this one because we were out of graph, but that's how easy it is to do. So this is a super, super easy page. So this is the mother function. Oh, and I forgot to write up here. I was telling myself, don't forget, when k is less than 0, which means it's negative, that's when the graph gets shifted down. So when you add a number at the end, plus 4 plus 6, it's called a shift up. When you subtract a number from the end, like minus 4, then it's a shift down. And you should know that verbiage because that's important for 150. Okay, so this one is the mother function added by 2. So that means shift up 2 units. So the mother function is at 0, 0. Remember how we said this is the mother function? I also drew it up here, but it's at 0, 0. So shift up 2 units means go up 1, 2. And then you do those points I told you to memorize. Right 1, up 1. Left 1, up 1. Right 2, up 1, 2, 3, 4. And we're always traveling from the vertex. Notice I always start at the vertex. Left 2, up 1, 2, 3, 4. And once you draw it, the points should be symmetric because parabolas are always symmetric. And then you draw it using nice smooth curve with arrows on both ends. No V at the bottom, nice smooth curve, arrows at both ends. So there is my beautiful parabola. I didn't have to make a t-table because I memorized the points. So if you want to put them here just to remind yourself, 0, 0. When I put 0 in for x, I get 0. When I put 1 in for x, 1 times 1 is 1. When I put 2 in for x, I get 4 because 2 times 2 is 4. So that's just the mother function, and that's what this is, the mother function, but shifted up 2. So let's do one more, and then you guys can try a couple. So this one is shifted down 3 units. So I take the mother function, whose vertex is at 0, 0, remember? And I shift it down 3 units. So 1, 2, 3. So there's my new vertex. And remember how we learned when the leading coefficient is positive, the parabola cups up. Positive, parabola cups up. If that had been a negative, you still shift down, but then the parabola would cup down. So down 3, and then we go over 1, up 1. Left 1, up 1. Right 2, up 1, 2, 3, 4. Left 2, up 1, 2, 3, 4. And there is our very most beautiful parabola. So we draw it nice and rounded, arrows on both ends. It's a little pointy, but we'll pretend that it looks rounded. Okay? So you guys got the hang of it? Okay, I want you to try the next two, but I'm going to give you a little heads up. These are negative, so you'll have to do your counting down. So go ahead and try those. Turn off the video, try them, and then we'll compare answers in just a moment. Okay, so this is an upside down parabola. How do I know? Because of the negative, and it's shifted up 5 units. I should write shifted because that's an important word. They don't like it when you say moved or lifted. They want you to use the math verbiage in the next class. So the first thing I do is I find my vertex. It was at 0, 0 for the mother function, but this says shifted up 5. 1, 2, 3, 4, 5. And then I do my 0, 0, 1, 1, 2, 4, but I do it going down. So right 1, down 1. Left 1, down 1. Right 2, down 4. Left 2, down 4. Is it symmetric? Yes, it is. So now I draw my graph. And it's usually easier if you draw half at a time. And you can make it rounded more easily. So there is my beautiful downward cupping parabola. And again, it's downward cupping because of the negative in front. These both had positives in front. That's why they cupped up. This one has a negative. Okay, next. This is the same thing as negative x squared plus 2.5. You can either put it in on your calculator, divide it in your head, divide it by hand, but 5/2 is just 2.5. So this again is a downward cupping parabola because of the negative in front, and it's shifted up 2.5 units. Shifted up 2.5 units. And we're going to learn about left and right shifting in a little bit. But this is one is shifted up. So both of these were plus. So they were both shifted up and they're both upside down. So up 2.5 units, you just go right in between 2 and 3. No big deal. Doesn't matter about fractions. And then you go over 1, down 1. So you're still going to be in the middle. Over 1, down 1. So you'll still be in the middle. Then you go over 1, 2, down 1, 2, 3, 4, stay in the middle. And then you go left 2, down 1, 2, 3, 4, stay in the middle. Because it's the mother function, and they call this a reflection. So it's the mother function reflected, which means flipped upside down, but raised 2.5 units. And then we